Good day to Professor Ho. My name is NADHIRAH. In this video, we will be presenting our topic for our group assignment, which is inverse of a matrix. First of all, I will be presenting the history of linear algebra first. In 1693, Leibniz had introduced determinants, and Cramer, the founder of Cramer's rule, had presented his determinant-based formula to solve systems of linear equations back in 1750. Around 800, Gauss introduced a way to solve a system of linear equation. Gaussian elimination, where the method are combination of interchanging two rows, multiplying a row by a constant, and adding a row to another row. Cayley defined matrix multiplication so that the matrix of coefficients for the composite transformation ST is the product of the matrix for S times T. Cayley also contributed to the idea of identity matrix and inverse of a square matrix. In the later parts, we will look into a few methods to solve inverse of a matrix and its application in real life.
Hi, I'm FITRIYANTIE and I am going to explain about two methods that are used to find the inverse of matrices. The first method is by using the adjoint method. The definition of adjoint is stated as the following. For the theorem stated, our formula is computed. We use this formula to find the inverse of matrix A on a condition where the determinant A must not equal to 0. For example, we apply this adjoint method for 2 by 2 matrix and there is 4 steps to find the inverse of the matrix A, which is as the following. Now for the 3 by 3 matrix, we use the same 4 steps just now to find inverse of matrix B. The second method is by using the property of AB equal to KI. In this method, we just need to manipulate the fact that AB equal to KI with the aim to find A inverse equal to something. These are the steps that are implemented. With that, we manage to find A inverse, which is equal to 1 over K times B. This is a formula that can be used to find the inverse of a matrix. Now, for example, we find the A inverse in the question of 2 by 2 matrix, where the matrix A, matrix B, and the constant are given. For this, we only need to substitute all of them into the formula obtained. Hence, the A inverse is obtained simply. Next, for 3 by 3 matrix, first we are required to find the constant K. To find K, we need to find the product of A and B. After we obtain AB, 2 is factored out from the diagonal entries respectively. Thus, K is equal to 2. Next, to deduce A inverse. From the AB equal to 2i, we can deduce A inverse as stated in the following. That's all from me. Thank you.
Greetings, Prof. Ho. My name is NURUL SYAZWANI and I will now explain how we will get matrix inverse by using elementary row operations. First thing first, elementary row operations include following operations, which are interchanging the ith row and jth row. Second, multiplying the ith row with a non-zero constant. Third, adding a multiple of jth row to the ith row. Okay, say that we are now finding the inverse of matrix A. So, in order to find inverse of matrix A, we have to change matrix A into identity matrix. And so, the augmented identity matrix will change to the inverse of matrix A. So, how to change matrix A into identity matrix? Here I include all the steps needed for elementary row operations, where we can change matrix A into identity matrix to find its inverse. Step 1, we have to obtain 1 in the first position on the leading diagonal. Step 2, we obtain zeros under 1 in the first column. Step 3, again we obtain 1 but in the second position on the leading diagonal. And step 4, again we obtain 0 under and above 1 in the second column. Step 5, we obtain 1 but in the third position on the leading diagonal. And step 6, we obtain 0 above all the 1. After doing all those 6 steps, we will get identity matrix on the left hand side and its inverse on the right hand side. Now, let's take a look with example of 2 by 2 matrix. Say we are given matrix A, as shown here, and we want to find its inverse by using elementary row operations. So we will begin by constructing a 2x4 matrix which contain matrix A at the left hand side and identity matrix at the right hand side. To find the inverse of matrix A, the same procedure as I mentioned before is used. After following the procedure before, we will get these elementary row operations. And finally, at the end of the calculation, we will get a form of augmented matrix where identity matrix is now at the left hand side and at the right hand side is its inverse, which in this case is its inverse is -5, 3, 2, -1. Next is example of 3x3 matrix. Say matrix B are given here. The same procedure is still used for this question, where first we begin by constructing a 3x6 matrix that contain matrix B at the left hand side and identity matrix at the right hand side. After performing elementary row operations, at the end we will get a form of augmented matrix where identity matrix is now at the left hand side and its inverse of matrix B is at the right hand side.
Assalamualaikum and hi everyone, my name is NURSHATIRAH and now I'm going to present about Gauss-Jordan reduction. Gauss-Jordan reduction is an algorithm that can be used to solve system of linear equation and to find the inverse of any invertible matrix. It relies upon 3 elementary row operation that can use on a matrix which has swapped the position of 2 of the rows, multiple one of the rows by a non-zero scalar, and adding one of the row to the other row. So this is the example for how Gauss-Jordan reduction works. The question said matrix A equals to A, B, C, D and matrix B equals to E, F, G, H. If AB equals to BA equals to I, by using the Gauss-Jordan reduction, find E, F, G, H in terms of A, B, C, D. Okay, to answer this question, the key is the equation of AB equals to BA equals to I. In this equation, I is the identity matrix. The meaning of the formula is, the meaning of this equation is A is the inverse of B and B also the inverse of A. The question asks us to find E, F, G, H in terms of A, B, C, D. This means that we need to find the inverse of A using Gauss-Jordan reduction. So for the first step, we form augmented matrix like this, where A at the left side and identity matrix at the right side. To find the inverse, we transform the augmented matrix to identity matrix form via elementary row operations like this. Okay, after we're done doing elementary row operations, the right side of the augmented matrix is the inverse of A. We will equalize the inverse matrix of A with matrix B so that we can find the values of E, F, G, H in terms of A, B, C, D.
Hi, my name is SITI NURMYDZSARAH and I'm going to present about the applications of inverse matrix. Basically, there are a lot of sectors that are using linear algebra, which also includes inverse matrix. For our assignments, we have chosen 4 sectors which are cryptography, digital image restoration, genetics and breeding, and computer graphic. The first one is cryptography. Cryptography is a practice to keep data and information secure. Inverse matrix is used to decrypt the encoded messages. The next one is digital image restoration. Digital image restoration is applied in many fields such as medical imaging and diagnosis to get clear images. Inverse matrix is used to test the algorithm for a better image. The third sector is genetic and breeding. Breeding needs inverse matrix to get a finest linear unbiased prediction for of breeding values. The last one is computer graphic. Addition, subtraction, multiplication and division of matrices have to be done, but since division of matrices does not exist, it is replaced by multiplying the matrix with its inverse.
In conclusion, there are various ways to determine the inverse of a matrix as shown before. Students might be thinking learning algebra in university level is useless, but as we can see, metrics definitely apply to solve problems in real-life situation. What we can do as a student is to appreciate all the efforts made by mathematicians, as they are the reasons behind all of these theorems in linear algebra come into pieces so that people can use it to solve problems.